All right, it says a particle moves along the x-axis so that at any time the velocity is given by that. We want the acceleration of the particle at t equals 4. All right, I don't have a calculator in front of me. I can pull one up if necessary, but let's just talk about some ideas here first. So if we have velocity, I mean, this is easy enough, right? And we want acceleration, we should just be taking the derivative of velocity and plugging in 4. And you can do that on your calculator. So anybody that did this for me, can you tell me what you got for an answer for number 1?
I got C.
Can anybody confirm?
I got the same thing.
Okay, that sounds familiar to me as well. So I'm going to say that number 1 is C. And we're getting that again by taking the derivative, using the calculator, and plugging in 4. All right, number 2. Figure above shows the graph of a function f. Which of the following has the greatest value? Greatest value. All right, so we've got this function f, and I don't know what we're talking about here, but we want to know the greatest value. So I'm just going to make a list here and see what we can come up with. This is going to be process of elimination. So if we look at choice A, all right, what do we know? F of A is equal to, this is the graph of F. So F of A is equal to, I don't know what that is, but it's a negative number. So for right now, I'm just going to go with negative. We'll see if that helps or not later. For B, F prime of A. F prime of A, that'd be the slope of that tangent line, right? So we know that's going to be F prime of A is going to be equal to something positive. All right, next one, F prime of C. Easy enough. That one's going to be 0. So F prime of C is going to be equal to 0. All right, what do we got for D? F of D minus F of A. So let's just, for an example, for a second, let's just pretend this is, I don't know, -5. Let's just go with that. F of D minus F of C. So that's going to be, let's just say, I don't know, 4 or like 3 and 4. Either way, these two numbers are super close, right? F of D minus F of C. It's going to be some sort of number, but F of D is going to be lower than F of C. So this would be like saying 4 minus 5 or 3 minus 4. It's going to be like a negative number, but a very slight one. Whereas the one from the original clearly was much less. Anyways, who cares? We're asking for the greatest value. And I already know this is a positive number. So I'm just going to still say this is a negative answer. We don't even care. Right now, it's looking pretty good that choice B is our winner, unless something happens here in that last choice. And what's in that last choice? That sounds like the slope formula. F of B minus F of A over B minus A. That's the slope from here to here. So the average rate of change of that slope. So that's going to be some sort of slope there. What can we tell about that slope in comparison? So that's going to be a positive slope. All right, so we got to talk now. So what do we think? What's going on here? What are our thoughts? Anybody have anything to add to this?
This was one that I was unsure of. I ended up choosing B, but I got to the same point and I was like, A looks slope, like steeper right at A.
Yeah, that's where I'm at right now too, Caroline. So I haven't looked at these in quite some time. I don't have the answers memorized. So as far as I can tell, if we make a slope from here to here, that one is going to be going underneath that line a little bit, versus if we drew a tangent line here, that one would be raising higher than the average rate of change. So from what I can eyeball, I would say that choice B would have the biggest number of these 5. So I'm going with choice B. Does anybody have any questions on that? Okay, C, or not C, I'm sorry, 3. Which of the following functions are continuous at 1? Continuous at 1. All right, so what's it mean to be continuous? Functions defined, limit exists, no holes in the graph, all that stuff. So, anybody got an answer?
I said that all of them were continuous, but I was kind of really unsure about this one.
Anybody else have anything? All right, so to do this, we got to graph this first off. We can remember it's a calculator question. So I'm pretty sure we can rule out this one because if I plug in 1, this is going to be natural log of 0. And you can't do natural log of 0. That gives you something that's screwed up. So natural log of 0, remember natural log of 1 is good, but natural log of 0 doesn't work. So I'm going to go ahead and say that that one is off the chart. Number 3 is gone. And then if we look at the other ones, natural log of 1 is going to be a fluid thing. We can do that. Natural log of 1 is 0. That's going to check out. And e to the 0, that's going to be equal to 1 if we graph e to the power of x. That's going to give us something. Let's take a look here. Let me try to pull up something. Let's see if Desmos does it for us. Okay, so let's look at. Okay, so if you look at the screen share, here's the graph of e to the x. So e to the x at 0 certainly looks continuous to me. Okay, so that one's good. And if we look at natural log of x, natural log of, not e natural log x, natural log x at 1 certainly looks continuous to me. And then the other one they had us look at was natural log, was it of e to the x minus 1, guys? Is that what it was? Did I copy that right or wrong? What was it?
Yep.
Yeah.
Is that right? All right, now, natural log of e to the x minus 1. And hold on, where did I go? Oh, they're continuous at 1. I'm sorry, why was I thinking 0? It was at 1. I think you are right, Helen. Why did I say 0 for this problem? So for the other two, I said 1, we're good. If we do e to the 1 here, e to the 1's whatever, minus 1, that's still going to be good. So if you look at the graph of that, remember, you're allowed to graph all of these. At 1, that also looks continuous to me. So I don't see any problems with any of these 3. So from what I can see, the answer would be E, which is 1, 2, and 3. Any questions there? Okay. Moving along to number 4, functions given by that. What's the average rate of change? Average rate of change just means to find the slope. So the average rate of change from 0 to 3. Now, remember, average anything is the formula, except average rate of change is just find the slope of what you got. So in this problem, what they're telling you is that you've got 0 comma something, 3 comma something. We want to find the somethings. We want to find the somethings and then find the slope. Okay, so this is a calculator question. So we need to do the integral from 1 to 0 of this thing. And then the integral from 1 to 3, we're plugging in for the bound, right? Of this thing. And we need to see what that gives us for each one of these. So I need you guys to go on your calculator, if you have one, and try this and see what you get. And then once we get these two ordered pairs, we are going to then find the slope with them. So let's start with 0. Somebody in there, go ahead and find me the integral from 1 to 0 of the square root of your calculator is going to be x to the third plus 2. Somebody find me that integral. Go. So we're plugging in 0 for the top bound.
I got 1.50.
1.50. Okay, find me the same thing for 3. Now we're going to go from 1 to 3, same function. 1 to 3, same function. See what we get. What we got? Anybody?
6.58.
6.58. Okay. 6. Okay. Now you still got a calculator, so go ahead and find the slope with these. This is going to be 6.58 minus 1.5 divided by 3, because 3 minus 0. So crank that out. Let's see what we got. What we got, guys? Anybody?
1.696.
1.696. There you go. Choice C. Any questions on number 4?
I have a quick question because like for the 0 one, because it's in the top integral, would it be negative?
Yeah, so your calculator will do that for you.
Okay.
If you're doing, I mean, it gives you that calculation by hand. If you're doing it by hand, then yeah, you flip the bounds and put the negative out front.
Okay. But then would it be negative 1.5 or positive 1.5?
Well, let me ask you this question. Enter it in your calculator with a negative sign out front and do it from 0 to 1 and see what it gives you.
Okay, got it. Okay, Thank you.
Well, now try it real quick. Tell me what you get. I want to make sure that I am telling you this correctly.
Give me a second.
I'm pretty sure it should give you something. The calculator, I believe, adjusts that for you when it's doing the calculation.
Because when I put it in, just like 1 to 0 or whatever, like how it is, I got it was negative 1.5. So that's why I wanted to clarify. But let me check super quickly. So now I get like a completely different answer, but I'm not quite sure.
When you do it from 0 to 1 with a negative sign out front, it's giving you something different.
Let me try it one more time. I could have put something in
Maybe the bounce. You may try to bounce, like put the bigger bounce on top and then the small one on the bottom.
Right. That's what we're saying. If we make the 0 on the bottom, the 1 on the top.
Yeah, because I got E. That's what people are saying in the chat. I got E because I got 2.69. Because when I did 1 to 0, it was negative 1.5.
Okay. I'll get a calculator out to play with it to see what it does. I don't have one in front of me at the moment. So when I'm at school tomorrow, I will grab one and I will give you a more clear answer on that.
Okay, awesome. Thank you.
All right, number 5, function shown above. For which of the following values does C, which of the following values of C does? We're looking for the limit as X approaches something. The resulting answer is 1. Which of the following, when we approach this thing, the limit value is 1? So I see a couple of them. If I approach -2 from both directions, that limit should be 1. If I approach 0 from both directions, that limit should be 1. So definitely -2 and 0. So I'm just kind of picturing like a horizontal line basically going across here at 1, and I'm seeing where these limits tie in. Now at 3, that's only going to work if it's a one-sided limit from the left, but that's not in any of our choices. So the limit as it just approaches 3 is D and E. So this should be -2 and 0, choice C. Okay. 6, let F be the function defined above where K is a positive constant. For what value of K, if any, is F continuous? So what's first thing we want to do here? We're trying to figure out values for K that would make this continuous. So I want to put in 3 for X. And then after I put in 3 for X, I want to set the top equal to the bottom. So if we put in 3 for X and set these equal to each other, because that's what would make it continuous, right? That's going to be K to the 3rd plus 3 is equal to 16 over K squared minus 3. So we've got our X values in. All right, let's see. So this looks like we're going to need a calculator, I'm assuming, based on these choices. If we try to solve this, I would treat this as a fraction equals a fraction and try to cross multiply this of some sort. So if I crisscross these, this is going to be K to the 3rd plus 3, K squared minus 3 is equal to 16. To solve this, this is a FOIL of some sort. So see what you get when you FOIL this. That would be first times first is K to the 5th. The outer is minus 3K to the 3rd plus 3K squared minus 9. I'm going to bring this 16 over and make it minus 16 is equal to 0. So you're definitely going to need a calculator for this. K to the 5th minus 3K to the 3rd plus 3K squared minus 25 is equal to 0. Anytime you're setting something to 0, you're looking for X-intercepts. So basically, we'd want to graph this. Let me try it in Desmos and see what we get. Did anybody get this? Crowd goes silent. Does that make sense though, what I'm trying to do right now?
Yeah, it makes sense.
Plus 3k squared minus 25. I'm having trouble getting my Desmos to work here. All right, another option we have here is you could just go into like graph this. It's not popping up for me in Desmos, but if you just traced to the three numbers that were here,
Mr.
one
Baker,
of them should give you 0. Yes.
I got 2.081.
Okay, it came up for you when you graphed it.
Yes.
Okay, cool. All right, so Desmos is not doing a trick for me, but a graphing calculator should. Sounding like 2.081. Okay, table above shows selected values of the continuous function f for 0 to 13. What are the fewest possible number of times that f of x is equal to 4? All right, now it's a continuous function. And this is the table for f, and they're asking you about f. So if you just kind of pretend in your mind where it's going, they're asking you how many times it has to be at least 4. So if I start at 3 and I go up to 4.5, we had to hit 4. So that's 1. Back down to 3, that had to hit 4. Down to 2.5, no such luck. But then up again to 4.4, it had to hit 4 again. So in that explanation, I see 3 times where it had to have been 4. Does anybody have any questions on that? Choice C for number 7.
Just so you know, you're not sharing your screen if you were trying to.
Thanks. I probably should do that. Thought I was.
But that does make sense.
So yeah, thank you. Sorry. Okay, same explanation. So I didn't really do much. It was just kind of talking it out loud. So from 3 to 4.5, just remember, picture whatever I'm drawing, it's got to be a continuous function. So that means I'm never lifting my pencil up. So on the journey from 3 to 4.5, you had to hit 4. On the journey from 4.5 to 3 back down, you had to hit 4. And from 2.5 to 4.4, you had to hit 4. So that's 3 times. That's not to say there aren't more times, but this is a guarantee that those 3 got to be 4 in there. All right, let f be the function given by that thing. Let g be the function given by that thing. What value of x do the graphs of f and g have parallel tangent lines? So I don't know. Let's take the derivative of each and go from there. So if we're talking about tangent lines, we want their slopes to be the same. So I don't know, what would the derivative be of 3e to the 2x? That's what, times 2. So I'm getting 6e to the 2x. And then on the other one, I'm getting, what, 18x squared? All right, so how do we go about solving this? This is algebra 2 stuff, so take it to the same side. So that's the same thing as saying that is equal to 0. So to solve this, to figure out where those two things are the same, I would just graph that now and see where the x-intercepts are at. Or other option is graph each one individually and see where the graphs intersect. Should be the same answer. Somebody either go do that for me, or somebody that did it tell me what we get.
I got negative 0.391.
Choice C. Okay. Does anybody have any questions on this one being choice C? All right. Going down here to number 9. Graph of y equals that, crosses the x-axis at one point on the interval 0 to 1. What is the slope of the graph at this point? So if you want the slope of a graph at that point, what are we being asked to find?
Derivative.
So now, in other words, this question is saying, find f prime of, now we need to know what that is, f prime of the x-intercept is what the problem says. Find x prime of the x-intercept. So in order to get going, we need to find the x-intercept. So start with e to the tan minus 2 on the interval 0 to 1. And first off, just find us that x-intercept. And then we're going to look for f prime of that point. So somebody find me the x-intercept first. Anybody? What's the x-intercept?
I said 0, -1 for the x-intercept.
The it's between 0 and 1. So the x-intercept for e to the tan x and then minus 2. So we want to go to your calculator and graph y equals e to the tan x and then outside of that minus 2. And we're only going to look at it on the interval 0 to 1. So we want to figure out where on that story does it cross the should be 0.606. So here on Desmos, here's the graph of e to the tan x minus 2. And then between 0 and 1, here's the intercept at 0.606. So you are looking for f prime of 0.606. So what is f prime? First off, the derivative would be e to the tangent x, that minus 2 is gone, e to the stuff prime. What's stuff prime? The derivative of tangent is secant squared, right? And then into this, you got to plug in 0.606. No clue what that's going to be. That's calculator bound. So e raised to the tangent of 0.606 times secant squared 0.606. You're going to have to play with the calculator there and see what you get. So also to give you guys some perspective, if you're panicking, I don't know where you're at this point. The calculator section is only 15 questions, and historically people get like half at best correct. This is not some section that you have to crush to pass the AP exam. Like if you get 5 or 6 of them out of 15, that's cool. This isn't something that we have to ace. You need to get, I've given you my spiel before about getting 20 of the first section. This one, I mean, if you scratch out 5 or 6 of them right, which I mean, just closing your eyes, you're going to guess 3 of them right. So, I mean, hopefully you can find a couple that you know. There's no way to study for this, right? This is just a mixed match of who knows what they throw at you. If you get 5 or 6 of these right, you're going to be fine. So this is not a section to really panic about. So you can kind of tell also by the amount of time we've allocated this year and where we have spent that time, tons and tons and tons of it on free response, tons and tons and tons of it on non-calculator multiple choice. That's where your score is going to be built from. Anyways, you would fire this into a calculator. You're going to get something. We're moving on. Cup of tea is cooling in a room, yada, yada, yada. What are we talking about? All right, the initial temperature. So we got this initial condition here. This makes me start to think FTC just off the bat. I don't know if that's true or not, but we have an initial condition that at T equals 0, that's the temp, and the temperature of the T changes at a rate of this. What is the temperature to the nearest degree after 4 minutes? So temperature's changing. They're giving us a rate. If you integrate a rate, you get an amount. So my instinct here is to try some FTC. If we integrate R of T, I'm not even copying the formula, but if we integrate R of T from something they give me to something I want, they give me 0 and I want 4. If I integrate the rate, I get an amount. That would be T of 4 minus T of 0, right? So to me, that would be what they give me for 0. 0 is 200. So, or we could go like little r of something of 4 minus 200, but I would just use T for temperature. So we would be add the 200 over, and it would be 200 plus this integral, I believe would give us the temperature at time 4. Does that make sense?
Yeah, that makes sense.
Okay, so you would fire that all into a calculator, you would get something. 11, changes concavity. All right, we need, what did you guys get for that last one? Did you get A?
Yeah.
All right, so we'll go with A for that one. 11, the graph of the function is this, changes concavity. I would be doing a second derivative test. So we would know that y prime is equal to x squared minus 5 plus 3 cosine x. Y double prime is equal to 2x, that 5's out of there, minus 3 sine x. So I would be graphing that. And now you're graphing what's the second derivative. So wherever it crosses, wherever it is 0 and changes signs would be your points of inflection, and changes concavity, so above to below. So think about it. This is a second derivative graph. We haven't done much with that. But if you graph the second derivative, above the x is going to be concave up and below the x is going to be concave down, because we're talking about the graph of the second. So, and those zeros would be the POIs where it changes from one to the other. So you would want to graph this and see where that occurs. Did anybody do that?
Quick question. I'm not sure if maybe I derived it wrong, but when I did the second derivative, I got 2x minus 2.
2x, hold on, did I forget a term? Hold on. Hold on, I think I skipped the term altogether. Hold on. The first derivative, let me do that again. The first derivative, y prime, is going to be what? X squared minus, I missed that term, minus 2x, sorry, minus 5 plus 3 cosine x. Our second derivative would be 2x minus 2 minus 3 sine x. Is that better?
Yeah, that's what I got.
Okay. So now, same story that we had just talked about, but this is what you would be graphing.
But it gives us a linear function, so it cannot determine the concavity from it.
Now, here's the thing though, you're graphing the second derivative. So you're just looking for where it goes from above to below.
I graph the second derivative and still gives me the linear.
It's okay if it's linear. Remember though, you're looking at the second derivative. So even if you have something, I'm just scribbling a line here. If that's your graph, that's cool. There's the POI. Above is concave up and below is concave down. You're not looking at the original graph. You are looking at the second derivative.
Okay.
I ended up getting B for this one. I'm just not sure if it's right.
Anybody confirm?
I got 1.027.
That's not a choice.
Could you show what we're supposed to be graphing again?
Here's the second derivative. And then we're looking for where it changes concavity. So that would be the zeros of the zero or zeros of that function.
It looks like it's B. 2.2.
That was what I remembered from memory. 2.21. It's been a year since I looked at it, but 2.21 was the number from my memory.
Great.
Okay. All right. So we got the idea down. Move from there. 12. If the derivative is given by this, which of the following values does x have a relative max? So it's a calculator question. Graph it. Look for the relative max. The second you graph it, you're looking at the graph of the derivative. Means you're looking for it to go above to below. See where that occurs at. Where does the graph go from above to below in your first derivative graph?
Mr. Baker, it's a stupid question, but how can you select E in the calculator?
There's a button for E. First column, I think. There's an E to the X key.
It's second and then divided.
There you go.
Okay, got it. Thank you.
Yep. Okay, we got anything for 12?
I might have graphed this wrong, but I think I got B.
Anybody confirm?
And
I also got B.
You got B too, huh?
Yeah, I did.
All right, we're going with B for that one. So you'd be graphing it and then looking for where it goes above to below. All right, two particles leave the origin at the same time. Their respective position functions are this and that. So we've got two position functions. For how many times do they have the same acceleration? What's the plan here, guys? We have two different functions. We have the position function for each, and I want to know how many times their accelerations match. Somebody give me a plan.
I found the second derivative for both of them and
I
then set
agree.
them equal to 0, or set them equal to each other, sorry.
Exactly. All right. So we've got, well, first one is y equals cosine 2t. So the derivative is negative 2 sine 2t. So the second derivative is negative 4 cosine 2t. And then for the other one, we've got 4 sine t. So that's 4 cosine t. So that's negative 4 sine t. I would want you guys to graph both of these individually and then see how many times they intersect. Take note that this is on the interval 0 to 6, so you should set your graph accordingly. Okay, pause for a minute and do that. Okay, what do we get? We get 3?
Yeah.
Yep, 3 is correct. All right, moving down to 14. Graph the function shown consists of 2 segments of a semicircle. Let G be defined by all this. What's the value of G of 5? So G of 5 would be the graph of this from 0 to 5. So we want the area from 0 to 5. So what do we get here? This area is a triangle and a half circle. So this is 3 by 1 is 3, cut it in half. So we got 3 halves plus, and then I see a half circle radius 2. So area of a circle is pi r squared. Pi, the radius is 2 squared. That makes 4 pi is the area of the circle, but it's a half circle, so we should cut that in half and call it 2 pi. And these are all above the x-axis. So this should be 3/2 plus 2 pi. 3/2 is the same thing as 1.5. Choice D. Okay, 15. On the closed interval 2 to 4, which of the following could be the function f with the property that, whoa, all right. Somebody translate this for me into English. Which one of these could have what? What's that 1/4 minus 2 out front? It's the same thing as the bounds.
Is it the average value formula?
Exactly, yeah, average value. It's saying the average value from 2 to 4 is 1. The average value from 2 to 4 is 1. Which of the following could have that? From 2 to 4, the average value is 1. So let's see.
I'm not sure if you want the answer, but or what I said, but I said D for this one.
Okay, how'd you get that?
I mean, I haven't looked at this in weeks. I don't actually quite remember, but I guess I just don't remember what I did for this one.
All right, let's take a look here. So if we did, like just say, for example, we did for letter D, say we did average value. So that's 1/2 times the integral from 2 to 4, and then you'd be finding the area of this shape. So if you found the area of this shape, what would that be? That's going to be 2 by, so we'll just call this the result. So if you find these areas, we should be able to match them up. See what we get here. So if you found this area for D, that's 2 by 1 is 2. And then this triangle is also 2. So to me, that would be an area of 4. And then 1/2 of 4 would be 2. So I think we can rule out D. Let's take a peek at C. If we did 1/b minus a, that's still the 1/2 times the integral from 2 to 4. All right, now that means we want the area from 2 to 4. So that's going to be these two triangles. So that's 1 times 2 is 2. Cut it in half is 1. So each of these triangles is 1. So that means the result of the integral is 2. And then 2 times 1/2 is 1. I'd be going with choice C for my answer. Any questions there? Any questions on anything? Okay, so I know that that's not the best section in the world, guys. I've been doing this long enough to know that the calculator multiple choice is kind of a mess. Do your best, use the clues that you know. Don't panic on that section. You're going to get 5 out of 15. Maybe you get even more. You might get 10 out of 15 or 12. Who knows? But don't panic if you're getting 5 or 6 out of the 15. That's not going to make or break your AP exam. You're going to get the handful rate that you can, and you keep on going, and you'll be just fine. So that's it. Mark that off as your score for your mock exam. We'll get into the free response questions probably tomorrow and Thursday to try to get a score for those. You can give yourself an actual score. And then we'll see where we're at. We'll keep going. So good job. Thanks for coming. I will talk to you guys tomorrow.
Thank you. Have a great night.
All right. See ya.
Mr. Baker, quick question.
What's up?
I ended up deciding that I'm going to do the AP Calculus and the AP Physics exams in the same day.
You're going to do it?
Yes.
All right.
On AP Classroom, I think, for some reason, I think I'm already signed up for the in-person one. And I'm not sure if there's a way to get that changed.
Say that again, on AP Classroom, you're signed up
Yeah,
for the
because on
in-person?
AP Classroom, it kind of like tells you what exam day you're like signed up for. And I'm pretty sure mine is like, it says that I'm signed up for the in-person May 24th exam. Even though I put on the survey that I was doing the June 9th one.
The survey that I sent around, that Google Doc.
Yeah,
you
and
put
I
it-
did it. I did. I think I might have, maybe I didn't. I could have forgotten to do it last week, but I think initially I was like thinking about doing the June 9th one anyways, but then I wasn't sure. But anyways, I was wondering if there was a way to fix that.
Let's see. I'm sure there is. Let me just send an email and see what we come up with here. So, actually, let's just give it. Well, no, I probably shouldn't. Hold on, let me send an email.
I can check really quickly just to like double check, but I'm pretty sure I was signed up for the 24th one.
So you're signed up. It's showing that you're signed up for in person, but you want to be online.
Correct. Yeah, it does say that I'm signed up for the in-person May 24th one as of right now, but I wanted to do the June 9th.
Okay, gotcha. I just sent an email to our department chair, and I will let you know what she says.
Okay, awesome. Thank you so much, Mr. Baker.
You got it. See ya.
Good evening.
Okay, bye.